Now, I really hope you've given this one a go before I go through it to think about how we could do this. How many ways are there of arranging the four letters A, A, B, C to give a different answer? Now, the key thing here is that if we have the string which is A, B, A, C, and I'm using colours here to differentiate the two A's, that is exactly the same as if we had A, but the other A, green A first, B, A, C. And those two things are exactly the same. Now, we could list out all the different options here. There aren't that many to list through, so that's possibly how you went about it. So let's have a think about how we could work this out without listing them all out. So the thing here is how many ways are there of doing it if the A's were different? So there was this color difference and there were different things. And that is, there are 4 factorial ways of doing it. So there are 4 factorial, which is 24, permutations. If the A's are different. But for each of those, there are 2 ways that we could have rearranged them. So for each of those 24 different ways, there are 2 ways that we could have ordered the A's. It could have been blue A, green A, or it could have been green A, blue A. So there are 24 ways of doing it in total, but for each of those, that includes 2 duplicates. So in total, we have 24, or 4 factorial, divided by 2, which is equal to 12. So there are going to be 12 ways, and maybe you listed them and you found those 12 ways. But what about if we have 5? 5 letters, and this time we've got 3 A's. Well, you could probably list them all out again and get there. It's not a huge amount of possibilities that we're going to get, but let's again think about how we could do it. And again, in a similar way, we're going to think about all the different ways we could have listed the 3 A's in different orders. So first of all, we've got B and C. I'm just going to write down a few B and C's here. And then we're going to think about, well, we could have had blue A, green A, and I need a new one. I'm going to go with pink A. Or I could have had blue A, pink A, and then green A. Or I could have had green A, then blue A, then pink A. Or I could have had green A, then pink A, then blue A. And you might notice that I'm being quite systematic here. Both the ones with blue A at the beginning, both the ones with green A at the beginning. And now I'm going to do the ones with pink A at the beginning. Could have had pink A, blue A, green A. Or I could have had pink A, green A, blue A. We notice that there are 6 different ways of arranging those 3 A's. And that's just 3 factorial, because we're thinking about how many ways could we arrange those 3 A's. So in total, we have 5 factorial, which is permutations where the A's are different. And then we have 3 factorial permutations of the a's. So in total, we have 5 factorial divided by 3 factorial, which is equal to 120 divided by 6, which is 20 possible ways that we could have arranged those 5 letters to get different answers, where the a's are all considered to be the same. So that they're not different a's, they're all just a's. We can generalize this idea into a formula. I'm not necessarily saying you need to recall this formula. I definitely don't. I tend to think of it in the way that we did it in those examples, but some people like the formula. So if we have n objects with k identical, the total number of permutations is the total number of permutations of the n objects as if the k identical ones were all different, and then divide by the k factorial ways of permuting those k objects, those k identical objects. So n factorial divided by k factorial works if we have k identical objects.